Now that we've introduced what polar coordinates are, and how to convert from polar to Cartesian and Cartesian to polar, it's time to deal with polar derivatives. First, just recall that we have x equals r cosine theta and y equals r sine theta in polar coordinates. And as we learned in the previous video, when we're graphing polar coordinates, or in general when we're writing equations for polar curves, we have r as a function of theta. R equals f of theta. So now we can just substitute this in when we're converting to Cartesian coordinates such that x equals f of theta times cosine theta, and y equals f of theta times sine theta, such that x and y are now only functions of theta. But now you should note that this is exactly like parametric coordinates, except that instead of t, our third variable here is theta. So therefore, the derivative dy dx should just be what we had for the parametric derivative, but this time with respect to theta. So dy d theta over dx d theta. Right? Note that for parametric coordinates we had dy dt over dx dt, but here our variable is theta. So now this is equal to, using the product rule, the numerator becomes the derivative of the first, f prime of theta sine theta plus f of theta times cosine theta. And the denominator becomes f prime of theta times cosine theta minus f of theta times sine theta. And as we had for parametric coordinates, you should note that the derivative is only defined if this denominator does not equal 0. So here, if we just want to write this in terms of r, we have this is equal to dr d theta times sine theta plus r cosine theta over dr d theta times cosine theta minus r sine theta. So let's just go through a quick example of evaluating a derivative in polar coordinates. Let's just try r equals 4 sine theta, a simple function. So here we should just know exactly what we need to know. We know sine theta, we have cosine theta, we have r already. All we have to find is dr d theta. So dr d theta is equal to 4 cosine theta. So now all we have to do is plug in. So we have dy dx equals dr d theta, so 4 cosine theta times sine theta, so 4 sine theta cosine theta plus 4 sine theta cosine theta by plugging in r over the denominator, which is 4 cosine theta squared, so 4 cosine squared theta minus 4 sine squared theta, where we can just cancel out a 4 in each of these terms. So now we have 2 sine theta cosine theta over cosine squared theta minus sine squared theta. But now you should note that we can simplify this further by using the double angle identities for both sine and cosine. The numerator is the double angle sine identity, sine 2 theta, and the denominator is the double angle cosine identity, cosine 2 theta. Since after all, this is not the base trigonometric identity because of this minus sign. So now since we have sine over cosine, we can rewrite this one more time as tan 2 theta. So this is our derivative in polar coordinates.